Has this ever happened to you?
Alright class, time to take UpCat.
Oh shoot, I didn't study. I hope it's all arithmetic math.
I hope you guys studied polynomials, cause it's the only thing on the test.
What the hell is that? I have no idea what that is. Only if I knew.
Hey juniors,
This is how to improve your life
with Crystal Math.
Crystal Math. Crystal Math is our review program for the CETs. Today we will be discussing polynomials. So, what are polynomials? When monomials are expressions with one term, binomials are expressions with two terms, and trinomials have three. Polynomials are basically expressions with two or more terms. Therefore, binomials and trinomials are also considered a polynomial. They are expressions that are composed of variables and coefficients that are combined through the means of addition, multiplication, and non-negative integer exponents. The word was first used in the 17th century, but can be traced back to the era of the Babylonians, and is derived from the Greek words poly, which means many, and nomial, which means terms. Binomials may be written as ax plus b, trinomials as ax squared plus bx plus c is equal to 0, and the most basic form of a polynomial may be written as shown. Now, several items that we've encountered in the CETs involve polynomials, and are usually easier to solve once you fully understand how to simplify and operate them through synthetic division and the remainder theorem.
Hey juniors! So now I'm going to be teaching you or giving you the definition on what is synthetic division. Synthetic division is a shortcut method of doing polynomial division and is only applicable when dividing a linear factor or a factor in its first degree. A more popular use of synthetic division, aside from dividing polynomials, is finding the roots of a polynomial. And here are examples to be shown.
For our first example, we will be considering the trinomial x squared minus 3x minus 10. We will be using long division to divide this polynomial by x minus 5. The first step is to place the dividend and divisor on the correct side of the division bar. When we start doing long division, we only divide the first term of the dividend by the first term of the divisor. In this case, we divide x squared by x and place the result on top of the division bar. Now, we take that x and multiply it by the divisor, x minus 5, using the distributive property of multiplication. We place the result underneath the dividend and align to the first term. Similar to division with normal numbers, we now perform subtraction. Take note to change the signs of the terms in the second line and subtract downwards. Next, we carry down the last term. Again, divide only the first term of the dividend and the first term of the divisor. In this case, we divide 2x by x. We replace the result on top of the division bar next to the first term in the quotient. Now, we take that 2 and multiply it to the divisor like we did previously. Again, we perform subtraction by first changing the sign of the terms in the second line and performing the operation. Since we have a remainder of 0, we can say that x minus 5 is indeed a factor of x squared minus 3x minus 10, with the other factor being the quotient, x plus 2. Another way of making sure that x plus 2 is indeed the quotient and the factor of x squared minus 3x minus 10 is to use synthetic division. Using synthetic division, we can evaluate whether or not this is true by dividing the polynomial by negative 2, and seeing if we end up with a remainder of 0. We first place negative 2, the test root, at the left and the numerical coefficients of the trinomial inside the bracket. We bring down the first coefficient. We multiply the carried down value by the test root and bring up the results up to the next column. Add down the column and repeat the previous step until all coefficients are dealt with. If we end up with the remainder, then the test root is not a real root of the polynomial. If the remainder is 0, then the test root is correct.
Another problem that involves long division is dividing x squared minus 4x plus 4 by x minus 1. First thing you do again is divide the first term of the dividend by the first term of the divisor and place the result on top. Then you multiply that value by the divisor. So you get x squared minus x. Once more, you subtract it, but first you change the sign to the second line and add downwards. So these two cancel out and you get minus 3x. You bring down that value over there and do the same thing. You divide the first term here with the first term there, and you multiply that value by this over here. You subtract them by changing the signs once more and adding downwards. Since we have a remainder, we know that x minus 1 cannot be a factor of x squared minus 4x plus 4. And the answer to this question is x minus 3 remainder 1. Another way to confirm this is by using synthetic division. Again, we have x minus 1 and x squared minus 4x plus 4. So our test root in this situation, since it's x minus 1 equals 0, our test root will be x equals 1. So you place that outside the synthetic division bar while you place the coefficients of the polynomial inside. You bring the first one down and multiply it to your test root. You bring that up and add downwards. Same thing, you multiply this answer by the test root and you bring it up as well. You will find that we have the same remainder when using synthetic division, which is remainder 1. In the CETs, you will be given a few items that require you to perform operations with polynomials, such as long division, as well as finding the factors of certain polynomials. Knowing how to do long division and synthetic division can help you answer these items easily and efficiently in order to attain the correct answer in the minimal amount of time.
What is the remainder theorem? The remainder theorem states that when we divide a polynomial f of x by x minus c, the remainder r equals f of c. Therefore, in order to find the remainder, we need not to use long division because we'll only need to evaluate the polynomial when x equals c.
Find the remainder when f of x equals x squared minus 3x minus 10 is divided by x minus 5. In order to find the remainder, we simply evaluate f of 5. F of 5 equals 5 squared minus 3 times 5 minus 10. F of 5 equals 25 minus 15 minus 10. Therefore, f of 5 equals 0. Find the remainder when f of g equals x squared plus 11x plus 3 is divided by g minus 2. In order to find the remainder, we simply evaluate f of 2. F of 2 equals 2 squared plus 11 times 2 plus 3. F of 2 equals 4 plus 22 plus 3. Therefore, f of 2 equals 29. Therefore, we conclude, when we divide the polynomial x minus 2, the remainder will be 29. Furthermore, x minus 2 is not a factor of the polynomial.
Knowing the remainder theorem can help you find the remainder of polynomial equations that require you to do division. This way, if you're required to find the remainder, you won't have to do synthetic or long division since you already know the remainder theorem and how to solve for the remainder easily.
Now that we've tackled the remainder theorem and synthetic division, we're going to move on to the factor theorem. The factor theorem states that when we consider the remainder theorem and evaluate f of c, if f of c equals 0, then x minus c must be a factor of the polynomial f of x. Since there is no remainder, like in the other previous example, when f of 5 equals 0, that indicated that x minus 5 is a factor of x squared minus 3x minus 10. This is useful because once you know that x minus c is a factor, you can know that also c is a root that can satisfy the polynomial. In summary, when f of c equals 0, then x minus c is a factor of the polynomial. And when x minus c is a factor of the polynomial, then f of c equals 0. Find the remainder when f of x equals x squared minus 3x minus 10 is divided by x plus 2 and determine if x plus 2 is a factor of f of x. F of negative 2 equals negative 2 raised to 2 minus 3 times negative 2 minus 10. Therefore, f of negative 2 equals 0. Since f of negative 2 equals 0, we can say that x plus 2 is a factor of x squared minus 3x minus 10.
Now we will use the factor theorem to determine if x plus 1 is a factor of f of x is equal to x squared minus 2x plus 1. To do so, we use the factor theorem and replace x with negative 1. So f of negative 1 is equal to negative 1 squared minus 2 times negative 1 plus 1 equals 1 plus 2 plus 1 equals 4. Since the remainder is not 0, x plus 1 is not a factor of the given polynomial expression. The factor theorem is a good piece of knowledge to have in addition to the remainder theorem, because in addition to the remainder theorem, the factor theorem helps you find out whether or not the expression is a factor of the polynomial expression. Once you know that x minus c is a factor of the polynomial expression, you also know that c is a root that will satisfy the polynomial expression, meaning knowing the factor theorem can help you efficiently solve polynomial expressions in a few items in your CETs. Time for you to try these items out on your own. The first item is use long division to divide x squared minus 13x plus 42 by x minus 7. Pause this part of the video and resume when you're ready to know the answer. This is the solution for the item. Divide the first term of the dividend by the first term of the divisor. Then multiply this by the divisor. Subtract these two by changing the signs and adding. Drop this one down, and same thing as earlier, divide the first term here by the first term there. And now multiply these two. Lastly, subtract these two and see if you have a remainder. Since you have no remainder, we know that x minus 7 and x minus 6 are the factors for this polynomial expression. The next item is use synthetic division to determine if x minus 5 is a factor of x squared minus 8x plus 16. Pause this part of the video if you're ready to answer, and resume when you're finished. We will now discuss the solution. Place 5 outside the synthetic division bar and the coefficients of the polynomial inside. So that will be 1, negative 8, and 16. Drop the first one down and multiply it to 5 and place the answer over here. You add these two and again multiply it to 5 and place the answer over here. Since we were left with a remainder of 1, we know that x minus 5 is not a factor of this polynomial, since we're left with a remainder. The next item is find the remainder when x raised to the 4 plus x squared minus 6 is divided by x squared minus 2. Pause this part when you're ready to answer and resume when you are finished. We will now discuss the answer. To answer this question, we will use the remainder theorem and substitute all the x's here by positive 2. So we will evaluate it when f is 2. So that'll be 16 plus 4 minus 6. The remainder will be 14. The last test item is use the factor theorem to prove whether or not x minus 6 is a factor of x squared minus 12x plus 36. Pause this part when you're ready to answer and resume when you are finished. We will now discuss the answers. Similar to the last item, we will use the remainder theorem first and substitute all the values here with positive 6. So that will become 6 squared minus 12 times 6 plus 36. Simplified, it will become 36 minus 72 plus 36. And the final answer will be 0. Since we're left with no remainder, we know that x minus 6 is a factor of the given polynomial expression. We have successfully finished our course on polynomials, synthetic division, factor theorem, and remainder theorem. The most important part about preparing for the CETs is doing it with the people you care about the most.
It's been a long day, my friends. See you again.
Work hard to get into the college you want to, because it really sucks if your friends get into college and you don't. And by the way, Enzo's ballpen is a screwdriver.
Ich bin eine Scheiße.
Nisiyatse, yitya handpao pao.
Tokyo.
Oh, I'm thinking!